Welcome to Ask and Learn.
All right, guys, we're doing problem number 40 of chapter 18 in Chemistry Essential Science. So the enthalpy of fusion of water is 6.01 kilojoules per mole. Sunlight striking Earth's surface supplies 168 watts per square meter. So assuming the melting of ice is due only to energy input from the sun, calculate how many grams of ice will be melted from a 1.0 square meter patch of ice over a 12-hour day. So let's say we're dealing with 12 hours. That's going to equal us 43,200 seconds. And so we just have to find the mass of our ice. So we're going to take 168 joules per second times meter squared. You multiply that by 1.00 squared meters. You multiply that by 43,200 seconds. You multiply that by 1 mole per, it's 6.01 kilojoules, so it's 6,010 joules. So let's start canceling out. This cancels out with this. This cancels out with this. This cancels out with this. And then we're going to multiply it by the molecular weight. It's 18 grams per mole. So we're going to multiply this out. 168 times 1 times 43,200 divided by 6,010 times 18. So that's going to be 21,737 grams of water. So now, B, the specific heat capacity of ice is 2.032 joules per grams times degrees Celsius. So C is 2.32 joules per gram times degrees Celsius. If the initial temperature of a 1.000 square meter patch of ice is -5 degrees Celsius, what is the final temperature after being in the sunlight for 12 hours? Assuming no phase changes, assuming the sunlight penetrates uniformly to a depth of 100 centimeters. So we're going to use Q is equal to MC delta T. Delta T, we're going to do delta T is equal to SQ over MC. So delta T is equal to, that's going to be the 160, that's going to be 168 times 1.00 times, and we're assuming we don't have phase changes in this S, and we're assuming we do not have any kind of what's the word? Phase changes. So we're not going to take account heat of fusion. (200) over 21,737 times 2.032. That means delta T is going to be equal to 164. (4.3 degrees Celsius). So delta T, that is equal to TF minus T initial. So that means that TF is going to be equal to delta T plus T initial. So TF is going to be equal to 164.3 minus 5. So TF would be 159.3 degrees Celsius. And you can see that this is a pretty drastic change, and that's because we're not including the energy we need for any kind of phase change.